Hello and welcome. So, you've done it. You've wrestled with the data, tweaked those hyperparameters, and you've finally got a machine learning model that you're actually proud of. That's a huge win. But that fantastic achievement brings us to the next big question.
What do you do with it now? I mean, how do you get that amazing model out of your cozy little notebook and into the wild, where it can be used by real people, handle real traffic, and do it all reliably and at scale? Well, that's the puzzle we're going to solve today. You see, in the real world, just being accurate isn't enough. Not even close. Your model has to be fast. That's your low latency. It needs to handle a flood of requests without breaking a sweat. That's high throughput. And what happens when you build an even better version tomorrow? You need version control, you need seamless updates, and you definitely need a way to roll back if things go sideways. This is the production checklist.
And that, right there, is exactly why we need dedicated model-serving platforms. The best way to think of them is as the essential bridge that carries your model from the quiet, predictable world of research over to the chaotic, demanding world of live production.
So, let's break down what these things really are. At their heart, they are super specialized systems designed to do one thing and do it incredibly well. Take your trained model file and transform it into a tough, scalable, and manageable production-ready service. They handle all the heavy engineering lifting so you can stay focused on the data science.
Now, what's really cool here is the contrast. I mean, sure, you could try to whip up a simple Flask API yourself, but you'd smash into scaling limits pretty fast, and you'd have no easy way to manage different versions or handle rollbacks. A serving platform, on the other hand, gives you all that right out of the box. We're talking auto-scaling, a model registry for versioning, and even advanced strategies like canary deployments, where you can test a new model on just a small group of users first. They completely fill that deployment gap. Okay, so now that we know why we need them, let's go on a little tour of the big three industry standards you're almost guaranteed to run into: TensorFlow Serving, TorchServe, and Seldon Core. First up, we've got TensorFlow Serving. And, as the name pretty much gives away, this is Google's own high-performance serving system, built from the ground up specifically for TensorFlow models. If you and your team live and breathe TensorFlow, this is your home turf.
And yeah, it comes with all the bells and whistles you'd expect from an enterprise tool. It handles model versioning like a dream, letting you serve multiple versions at once. It's totally optimized for insane throughput. It plays nice with Docker and Kubernetes, and it gives you both flexible REST endpoints and superfast gRPC endpoints to talk to your model.
All right, let's hop over to the other giant in the deep learning universe, PyTorch. For that, we have TorchServe. This is the official solution, backed by AWS and Facebook, and it's quickly become the absolute standard for getting PyTorch models out there, especially for things like computer vision and NLP.
TorchServe really shines with features like batch inference, which is a clever way of grouping requests together for huge efficiency boosts. You can also serve a bunch of different models from a single spot, and it comes with logging and monitoring baked right in. And of course, it's ready to go on Kubernetes.
And finally, there's Seldon Core. Now, Seldon is different. It's not tied down to just one framework. It's a seriously powerful open-source platform that was designed from day one to be Kubernetes-native and completely framework-agnostic. This is the go-to choice for complex, mixed framework environments. This is where Seldon really flexes its muscles. Because it's built for Kubernetes, it can manage incredibly complex deployments, it has built-in native support for A/B testing and canary rollouts, it can even plug into tools for model explainability and detecting data drift. But the killer feature? It works with TensorFlow, PyTorch, scikit-learn, you name it, anything. So, we've met our contenders. Now for the main event. How do they actually stack up against each other? Let's get into the showdown.
Okay, the first and probably biggest difference is framework support. It really is this simple. TensorFlow Serving is for TensorFlow, TorchServe is for PyTorch, and Seldon Core is for, well, everything else. This is your first major decision point. If your company is using a mix of frameworks, Seldon just jumped way ahead.
Next up, let's talk Kubernetes integration, which is, absolutely critical for modern MLOps. TensorFlow Serving and TorchServe can totally run on Kubernetes inside a container, but Seldon Core is natively built in. It literally speaks the language of Kubernetes using custom resource definitions to manage everything. It's just a much deeper, more powerful way of doing things. Now, this table really pulls it all together. As you can see, they all nailed the fundamentals, like GPU support and model versioning. But just look over to the right at the more advanced MLOps features.
For things like native A/B testing and first-class support for explainability, Seldon Core is the undisputed champ. This is what separates it from just being a model server and makes it a true orchestration tool.
So, with all of this info swirling around, how in the world do you actually pick one? Don't worry, let's boil this all down into a super simple, practical guide to help you choose the right tool for your job.
Okay, here's the bottom line. If your world is 100% TensorFlow models in a big company setting, TensorFlow Serving is a perfect, highly optimized choice. If you're all in on PyTorch for things like vision or NLP, TorchServe is your best friend. But, and this is the big one, if you're juggling multiple frameworks or you need those advanced deployment strategies on Kubernetes, then Seldon Core is the answer. It's pretty much that straightforward.
All right, before we wrap this up, let's just quickly run through a few pro tips and final thoughts. Think of it as your deployment playbook.
These are the golden rules, seriously. Always containerize your work with Docker and use Kubernetes to manage it. Use a model registry like MLflow. It's like a library for your trained models. Version everything, your code, your data, your models. And please, I'm begging you, never ever push a model into production without solid monitoring in place to track its performance and health. And on the flip side, here are the traps that lead to those 3 a.m. production fires. Just don't serve your model with a raw Flask app. Don't fly blind with no monitoring. Don't forget about auto-scaling, version control, or having a rollback plan. These aren't nice-to-haves. They are absolutely essential for doing MLOps professionally.
And that really brings us full circle to the core idea of this whole explainer. A model that just sits in a notebook, that's research. It's an experiment. It only becomes a real value-creating production asset when it's live on a serving platform, handling real traffic and making a real impact. So the only question left is, what's your next model going to be, research or production?